Hi, welcome back. I'm welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest learning platform. It is India's largest online learning platform. We are happy to announce that we are going to start a online training for the students who are going to writing the GATE and engineering service examinations. Okay, we started online training for them. Now here classes are taken care by India's top educators as well as experienced faculty. Okay, about myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. First, we check how to get the Unacademy learning app into your device. Okay, just go to Play Store in your device. Type Unacademy in that. By typing Unacademy in that, you will get the Unacademy learning app like this. Now just click on this install button here. By clicking on this install button, it will install the Unacademy learning app into your device. Once you open that device, open that app in your device, it will shows what are the different courses available in Unacademy. Okay, and in each course what are the different subjects and the respective faculty who are handling that subject. Okay, that data, that information you get in that. Now here are the few of the top educators from Unacademy. Tiwari sir, he is the IIT topper. He has 7 years of GATE and engineering service examinations experience, and he is the author of the textbook GATE in 75 days. Ankit Goyal sir, he got 2 times All India first rank in GATE electrical, and he was awarded President of India gold medal in IIT Indore. And Jaspal Singh sir, he is ex-IAS officer. He got All India 4th rank, and he is the ex-senior faculty member from MedEasy. And Sanchit Jain sir, he has a more experience. He is more than 8 years of experience he has. He is handling the subjects for computer science students. Because of these things only we are claiming that top educators are going to be handling the subjects here. Okay. Now here are few more top educators from Unacademy. Few more top educators from different departments. Now see this. We are going to conducting a test series for service examinations, engineering service examinations test series 2021. It was curated by best educators, and all India rank we are going to providing, okay, is provided if test is taken live. By live action, if you take the test, you will get a all India live rank, and it was designed as per the changed demand for service examinations. Okay, now in this we provide 10 questions to you, and the time slot for that one is 20 minutes. Okay, and this is for different departments. Now the different departments and the respective dates is mentioned here. For mechanical it is 22nd and 29th March. For electrical it is 23rd and 30th March. And for civil it is 24th and 31st March. And electronics and communication engineering 25th March. Last but not least, general studies is common. It is on 26th March. Okay, here is the general studies. It is on 26th March. Now, to unlock that, use my code VRAW10. By using my code VRAW10 during the exam, you can unlock that. Now, full length mock test. Previous one is 10 questions we given. Now there is a full length mock test also is there. There are 150 questions and 180 minutes of duration. Okay, and it was also created by the best educators. All India ranking is provided if test is taken live and designed as per the changing demand for ESE. Now 150 questions and 180 minutes of time. Now this is for mechanical engineering students, electrical engineering, civil engineering, as well as electronics and communication engineering. Okay, the test is started at 10 a.m. on 21st and 28th of March. Okay, this is the full length mock test. To unlock that, use my code VRAO10. Now, yeah, this is the golden opportunity to civil engineering students. Topic wise test series is there. These are the different topics and respective dates. By joining with the Jaspal Singh sir, okay, you can write this test series. You can complete this test series. Okay, now already I explained about sir. Sir is the All India top rank, All India 4th rank in engineering service examinations. Okay, now crack your engineering service examinations with Jaspal Singh sir by taking the support from him. And to unlock that, use my code VRAO10. So next, Ultimate 10 SSC series. This is for mechanical engineering students. Just we give 10 questions, 20 minutes of time. Now the exam is going to start at 10 a.m. at different dates. 1st March, 4th March, 9th March, 12th March and 17th March. These are the dates for mechanical engineering students. Okay. You can attempt the test if you are busy with that on the days for attempting online. You can attempt that one by offline also. Okay. You can attempt that by offline also. Now we move to another department, electrical engineering department. This is the same 10 ultimate 10 SSC series, 10 questions, 20 minutes of time. 2nd March, 5th March, 10th March, 15th March and 18th March, and it was started at 10 a.m. Okay, so you can attempt this similar to the previous. You can attempt the test after online also. Okay, by offline also you can attempt it. Next, ultimate 10 SSC series for civil engineering. So for civil engineering students also is there. It is at 10 questions and 20 minutes of time. 3rd March, 8th March, 11th March, 16th March and 19th March. The timing is 10 a.m. Okay, use my code VRAO10 to unlock this series. Okay, and you attempt the test by online, your online All India online rank also provide to you. Next, GATE or ride. So just quick start your GATE 2022 preparation. Now there is a 10 questions for 20 minutes of time. It was on every Tuesday, Thursday and Saturday at 10 a.m. This is going to be conducted. Okay, every Tuesday, Thursday, Saturday at 10 a.m. it is going to conduct. And this is for mechanical engineering, electrical, computer science and IT department, chemical engineering, electronics and communication engineering and civil engineering students. Okay, and to unlock the test, use my code VRAO10, and it was prepared by best educators, and All India rank is provided if test is taken live. It is designed as per the changing demand for GATE. Now see this, there is now we are happy to announce that recently we started 2 new batches, one for GATE 2023, other one is for GATE 2022. There is a Ascend batch for GATE 2023. Okay, this is for mechanical engineering. It was started from 22nd February 2021. Okay, use my code VRAO10 during subscription to get 10% discount. VRAW10 to get 10% discount. Here are the top faculty, top educators who are handling the subjects in this. Next, there is a evolve batch for GATE 2022 for mechanical engineering students. This batch started from 22nd February 2021. Okay, and the same faculty who are handling the GATE 2023, the same faculty are handling the subjects here. See, the faculty who are handling the GATE 2023, the same faculty are handling the subjects here. Same faculty. It was also started from 22nd February 2021. Next, we move to Spark batch for GATE 2022 for civil engineers. Spark batch for GATE 2022 civil engineering. This is only English batch. Okay, and this was started from 22nd February 2021. Now, there is a mission DDR for mechanical engineering students. It is very important. We started this batch with the intention to get every student of this batch has to get a good rank. With that intention, we started this one. This is for mechanical engineering students. For mechanical engineering students. Okay, and it was started from 22nd February 2021. And the top educators in this is Tiwari sir, Umaheshwara sir is the well familiar faculty in south side. For south side students, sir is a well known familiar faculty, and Meenu Gupta ma'am and Aman Raj sir are the top educators. Now we are moving to civil engineering. There is a Ascend batch for GATE 2023 for civil engineering. This batch started from 8th February 2021. Here are the top educators who are handling the subjects in this batch. And don't forget to use my code VRAW10 during subscription to get 10% discount. Okay, don't forget that. Now, the same team of civil engineering handling the subjects for GATE 2022 also. It was also started from 8th February 2021. Now we are moving to computer science and information technology. So there is a evolve batch for GATE 2022 for computer science and information technology. So the faculty in this one is Ravindra Babu sir, Sanchit Jain sir, Subbarao sir, Mallesham sir, Vishwadeep sir, and Sweta Kumari ma'am. Here are the top educators working under this batch. And this batch started from 8th February 2021. Ravindra Babu sir, he is the first faculty who started online training GATE for computer science students. Okay, and use their services, get the more benefit. And there is a Ascend batch for GATE 2023 for electrical engineering students. This batch started from 1st February 2021. So more number of faculty, because in electrical more number of subjects is there. Subjects are there, because of that here more number of faculty. Okay. Now we move to electronics and communication engineering. For electronics and communication engineering, there is a Ascend batch for GATE 2023. This batch started from 1st February 2021. Here are the top faculty who are handling the subjects in this. And don't forget to use my code VRAW10 during subscription to get 10% discount. Now there is a evolve batch for GATE 2022 for electrical engineering. The same faculty who are handling the subjects in GATE 2023, here also the same faculty are handling the subjects. Now we move to the electronics and communication engineering. There is a evolve batch for GATE 2022 in electronics and communication engineering. Now this batch started from 1st February 2021. Here are the top faculty who are working under this. Don't forget to use my code VRAW10 during subscription to get 10% discount. Now last but not least, we are moving to chemical engineering department. There is a eval batch for GATE 2022 for chemical engineering. This batch started from 25th January 2021. Okay, here are the top faculty, top educators who are working under this batch. Bansal sir, Shailendra Kumar, Devendra Punia, Manish Rajput, and Prajapati. Okay, here are the top educators who are handling the subjects in this. And don't forget to use my code VIRAO10 during subscription to get 10% discount. Now just we glance what are the different engineering disciplines available in Unacademy for GATE and engineering service examinations. Mechanical engineering, electrical engineering, civil engineering, production and industrial, instrumentation engineering, computer science and IT departments, chemical engineering, last but not least, electronics and communication engineering. Okay. Now we move to subscriptions. There are two types of plans here for subscription. There is a plus plan and iconic plan. Plus plan is the basic plan, and iconic plan take your preparation to the next level with a personal coach. Here we are providing the personal coach to you, personal coach to each and every individual student. Please underline that. We are providing a personal coach to each and every individual student. Okay, here in both the case, India's best educators are handling your classes. There are interactive live sessions also is there, and structured courses and PDFs are provided to you. Live tests and quizzes are there. Now the purpose of this personal coach is going to show the difference here from plus plan to iconic plan. Here we are showing the difference. Here, once you've written the exam, your paper is going to be analyzed thoroughly by a personal coach who are provided to you. He will identify where you are strong, where you need much preparation, where you are doing mistakes, okay, and where you are getting confusion. Everything they will analyze, and based on that they will prepare a proper study planner to you, and they will prepare proper study material also to you. By providing these two, by following these two effectively, every student can get success in their examinations, can get success in their examinations. Simply by providing a personal coach to you, we are going to identifying the gaps in your preparation, identifying the gaps in your preparation, and we are going to fulfill those gaps, fulfilling those gaps. Okay, they are the thing we are doing with personal coach. Okay, now we are moving to a plus plan. In plus plan there are different subscriptions are there. 1 month subscription, 3 month subscription, 6 months, 1 year, 1.5 year, and 2 years subscription. As a faculty, I recommend the students to take minimum of 1 year subscription. Minimum of 1 year subscription. Why? Because to attend all the classes and to prepare all the subjects, to write more number of tests, topic wise exam, subject wise exam, as a grand tests, more number of exams has to be right, and identify the gaps in their preparation. Student has to identify that, and to fulfill those gaps, number of times they has to revise the subject, revision the subject number of times, and whatever the tests they've written, they has to analyze the each and every test. Okay, they has to check whatever the questions they done mistake in the examination. They have to collect, they have to check everything, they have to collect. Okay, and to fulfill the gaps in their preparation, for every student minimum of 5 years of, so 1 year of time is required. Okay, so because of that I am recommending the students to take minimum of 1 year subscription. The cost of this one is 30,250. By using my code VRAW10 during subscription, it became 27,225 rupees only. Now, what is this amount? How much it is? In this amount, just compare this amount with transport charges. That means, for example, you joined outside. You joined outside to take a training. You joined outside to take a training. Okay. Once you join outside to take a training offline, throughout year you need to attend the classes. Now, here attending the classes during public holidays and weekends. Public holidays and weekends you are going to attending the classes. Okay, now here for traveling purpose, to travel from your home to that institute location to and fro throughout year, the transport expenditure is close to the amount of 20,000 plus. By adding little bit amount to that, you can get the benefits more than that. And one more important point here I am giving is, this is very important point, my dear students. The time what you need to spend for traveling is a minimum of 2 hours plus per day. Okay, if our time is not good, if any traffic is there, now it goes to 3 hours plus. Now you can save that 2 hours plus to 3 hours of time. If you spend that time for your preparation, whatever the topic you are going to be attending online, you can view that topic or you can cover that topic. Within that 2 hours of time, you can complete the preparation of the topic. That is the benefit you get. So by staying at your home itself, by staying at your room itself, okay, now with the help of your desktop, laptop or mobile, you are going to getting more benefits. You are getting more benefits. Okay, so my dear students, please think once of it. Okay, and take a right decision. That decision will change your life and you should be at a good position. Okay, now we are moving to another plan, iconic plan. In iconic plan, only two subscriptions are there, 1 year subscription and a 2 year subscription. 1 year subscription is 50,250 rupees. 2 year subscription is 74,000. Okay, now in this 50,000, by using my code VRAW10 during subscription, you get it by 45,225 rupees. And don't forget that here we are going to providing a personal coach to you. We are providing personal coach to you. Now the purpose of personal coach is, after writing the examinations, identifying your strengths and weaknesses in the examination. That means to identify the gaps in your preparation and to fulfill those gaps and to make you ready for the examination. That means like a loaded gun. Okay, we are going to providing a personal coach to you. Okay, now because of that we are charging this much amount. See, but this amount is, if you compare this amount with the amount what you are paying at outside institutions for taking the offline training, this is the amount more or less close to that. In some institutions the amount is more than this, more than double, close to that. Okay, 1.7 times, 1.8 times you need to pay compared to this in some institutions. But with this amount of little bit amount only, you are getting more benefits. No need to travel anywhere. Just by staying at your home itself, you are going to be you can classes and you are going to saving nearly 2 to 3 hours of time. time. Per week, if you take 2 hours of class, nearly per week you are going to saving 5 hours plus 5 to 6 hours of transport journey time you are going to saving. Okay, and to attend the classes we have to prepare half an hour at home. That means nearly 1 hour, half an hour plus half an hour, 2 days weekly, 1 hour, nearly 6 to 7 hours of time you need to save. And that 6 hours of time if you are spending your for preparation, every week you can complete nearly 20% of the subject. Okay, so, and at the same time we are going to providing a personal coach. That personal coach is going to perform his work effectively. He will provide whatever the information you want effectively. So my dear students, please don't waste your time. Whatever the thing is happened at outside, okay, it is happening, but your learning process should not stop. Your learning process should continue. Okay, so please discuss with your friends, family members and the faculty members who are having idea on GATE and engineering service examinations. Okay, take a red decision. That decision has to change your life and finally you should be at a good position. Okay, you have to enjoy your life beautifully. That is our intention. Now thank you, thanks for spending your time. Now we are going to moving to our today's topic is Jfet, Junction Field Effect Transistor. Already in previous session we discussed something about this. Just 2 minutes I rewind that and next I go to the next topic. So first I defined a transistor. Transistor is basically it provides current at output, and this current can be controlled by either input current or input voltage. If you are controlling this by using input current, that is called current controlled current device. Example is BJT. And if you are controlling that output current by using input voltage, that is called voltage controlled current device. That is called voltage controlled current device. And one more device we have, that is a voltage controlled voltage device. The example for this one is op amp. Op amp is a voltage controlled voltage device. Okay, now we are going to discussing here about FET, field effect transistor. A FET is a field effect transistor. Just a minute, sir. Now see this FET, field effect transistor, FET. The working principle of this FET is field effect. What is this field effect? Now, field effect is, it is the process of modulation of longitudinal current flow between two terminals of the device by a transverse electric field applied to the third terminal. There are the two terminals. Between these two terminals, a longitudinal current, that means current is going to be controlled. Current is going to be controlled between these two terminals. That is the meaning of modulation. Current flow between the two terminals by applying a transverse, means perpendicular, a perpendicular electric field applying to this. So by applying this electric field, we are going to controlling the current flow between these two terminals. That is the field effect. Now this electric field we are applying by applying a voltage across this. By applying a voltage, we are going to controlling that electric field. Okay, we are providing that electric field. By providing electric field, we are controlling the current flow. That means we are modulating the current flow. Now this is the overall FET. In FET basically three terminals is there: gate, source, drain. Now this is the best example for that operation of a FET. Source is there. Let us compare this with a source of water. It is in a bowl and there is a tap at one end. This now here is the drain. This is going to collecting the water from which are coming from source. Okay. Now there is a tap, that means gate I connected at source. Now if you open the gate, water in the source, the water in the source if I open that, a water in the source is going to be coming out. Water in the source is coming out. If you close the gate, that means if you close the tap, flow of water is going to be stopped. By the way you are operating the gate, flow of water from source to drain is going to be varying. Okay, flow of water from source to drain is varying by changing the operating the gate, that means by operating the tap. Okay, the same way now I am applying this one to the FET. That too, here water is nothing but a charge carriers. Now the flow of carriers from source to drain is controlled by gate. The flow of carriers from source to gate, flow of carriers from source to gate, flow of carriers from source to drain is controlled by gate, that is the FET. Okay, now here if we are using a gate terminal even for a lifetime, we are using that for a lifetime, it doesn't provide a single water drop to you. Okay, I purchased a tap and I am using that one for a 10 years. I used that. Okay, even I used that one for 10 years or 20 years, it is not going to providing single water drop to you by its own. Okay, it is not providing single water drop in this sense. It is not providing any gate current. It is not providing any carrier. Once not providing a carrier, gate current should be 0. So that is the gate current 0. And one more thing here. Once gate current is 0, now the source current is equals to drain current. So whatever the source carriers you have in source, the total carriers are reaching the drain. That's why source current is equals to drain current. So if you understand this slide effectively, then the FET is more or less you understand. Now field effect is the principle of operation we said. Okay, now by which technique we are going to be applying this to realize this field effect? What is the technique we are applying to realize this field effect? First one is Jfet. These are different types. Second one is MESFET. Third one is MISFET. Jfet means junction field effect transistor. MESFET is a metal semiconductor field effect transistor. MISFET is a metal insulator field effect transistor, and it is also called as MOSFET or IGFET. IG means insulated gate field effect transistor. Okay, now here we apply the field effect principle by applying a voltage across PN junction in Jfet. In MESFET, by applying a voltage across metal semiconductor contact. That metal semiconductor contact is a rectifying contact. One more thing, that is a rectifying contact. Basically between metal and semiconductor we have two types of contacts. One is a rectifying contact, other one is rectifying, other one is Schottky contact. Okay, now the difference is from one contact to another contact is a difference between the work functions of metal and semiconductor. Just by comparison of work functions, that contact type is going to be changed. Okay, so that is about this. And next, MOSFET. In MOSFET, there is a voltage across the metal oxide, metal oxide, metal oxide. That means between metal and insulator, there is a insulator, metal and insulator. You are going to applying a electric field by applying a voltage at gate terminal. That is a metal insulator field effect transistor. Okay. Now see this. Now about some important points about FET is a unipolar device. That means current is due to majority charge carriers. So it is a less temperature dependent and more immune to radiation. So it is a fabrication of FET is simple. It is compared to BJT, less number of steps. They occurred less area. They occupy less area on chip. And the way how field effect we are going to be obtained in different FETs is like this. Now we are moving to Jfet. We have two types of Jfets is there, N channel Jfet and P channel Jfet. In N channel Jfet, current is due to electrons. In P channel Jfet, current is due to holes. Default FET is N channel Jfet. Now this is the construction of this. Basically it has a source, drain and gate terminals. Okay, this is the construction of it. Now I am going to operating this. Say this. Now I am going to operating. Now in this gate, source and drain terminals are there. While operating this, a voltage is applied at gate and drain with respect to source. So during operation of Jfet, operation of Jfet, a voltage is applied at gate and drain terminals. Drain terminals with respect to source. With respect to source terminal. That means now VGS and second one is VDS. It is the voltage between gate, voltage at gate with respect to source, and this is the voltage at drain with respect to source. Okay. Now voltage at gate or gate to source voltage, we called it gate to source voltage. And this is, it is drain to source voltage. Drain to source voltage. Drain to source voltage. Here now the VGS is going to be applied such that the gate current should be equal to 0. VGS is applied such that the gate current Ig equals to 0. So with this intention it has to be applied. Finally you need to get a gate current 0. To get the gate current 0 you need to apply a suitable VGS value. Okay, it is either positive or negative. That depends on the type of Jfet. Either N channel Jfet you are going to, or you are going to P channel Jfet. Okay. Now, first case, let us, I am going to, before going to doing the proper operation of that, I am going to taking the, I am not going to applying any VGS, any VDS. Initial one. Now let us take step 1. In step 1, I am going to, so VGS is equals to 0. That means I am not applying any voltage between gate to source, as well as VDS also 0. Once VGS equals to 0 and VDS equals to 0, your FET is going to be shown like this. Your FET is like this. So this is your FET. Yes, FET is like this. Now there is a terminal at this end, source and drain. It is doped with P plus impurity on both sides. P plus impurity. This is your FET. Now there is a depletion region. We can expect a depletion region here. A depletion region I am expecting. And that too, it is extended more towards lightly doped N region. We are not applying any external voltages. That's why there is no extension of depletion region. So this is P plus, it is P plus, it is P plus, it is lightly doped N-type semiconductor. This is lightly doped N-type semiconductor. And we called it as channel. This is called channel. Okay, that is the channel. Okay, now So once you are not applying any voltage and any voltage externally, and it is a, let us take it as a source and it is a drain under this, that means this is under equilibrium condition. That means you are not applying any external biasing. So under steady state it is. So under steady state or under equilibrium. So yeah. Under equilibrium, it is going to provide some resistance to you. That is called drain to source resistance. Now the resistance what it posed is, I am representing by a letter R naught. Is you know that rho L by A, rho L by A. Here L is the length of the channel. So this is the length of the channel. This is the length of the channel. This is L, channel length. Rho, resistivity of the channel, and this channel is a basically n-type semiconductor, lightly doped n-type semiconductor, and I'm writing this R naught also. L by rho became sigma conductivity into area A. Area is the cross sectional area. Okay, now if you observe one thing, this is only a two-dimensional representation of the FET. Okay, now for better understanding we go and take the three-dimensional representation of it. Now I'm taking the three-dimensional. See this? Now for better understanding I am taking three-dimensional. This is the three-dimensional. This is the gate. This is the depletion region. This is the gate terminal. Gate it is. Source and drain terminals. Now see this. Now I am taking the another direction. See this? So this is the direction. Now this is, let us take it as Z. I am representing this one by Z. Okay, and this is the complete channel what we have. This is the complete channel. Sir, for better understanding, I want to draw more number of diagrams. This is the channel, complete channel. Now I am going to representing that complete channel by a letter 2A. This is the value 2A. Okay, 2A is the complete thickness of the channel. Complete thickness of the channel. Now this is the depletion region width. Here we have a depletion region width. Depletion region width W naught. Depletion region width is W naught. Now the net channel is this is going to be the net channel. This is the net channel available for conduction. Now its value is it is it is 2A, it is a W naught, 2 W naught, 2A minus 2 W naught. So that is a 2A minus 2 W naught. Okay, now I am writing its cross sectional area. Therefore, its cross sectional area is Z into thickness of the channel. Thickness of the channel is 2A minus 2 W naught into Z it is, which is 2 times A minus W naught into Z. Our intention is to calculate the under steady state or equilibrium conditions its resistance R naught, which is rho L by A. Rho is written as 1 by conductivity into area, and the channel is n-type semiconductor. Here channel is n-type semiconductor. Okay, so therefore channel conductivity is sigma, which is n into q into mu n, but it is n is nd here, nd into q into mu n. This is the sigma value. Now take this value and substitute in that. Now R naught is L by sigma is nd into q into mu n into area 2 into z into A minus W naught. So for we derived under steady state equilibrium its resistance, it is L by N2 into Nd into Q into mu n into Z into A minus W naught. This is the resistance. Okay, now here 2A is channel thickness, and Z is the width of the channel or channel width. So channel it is, that is channel. That is the channel. Very sorry, by mistake I have written. Now this is a channel. This is 2A is channel thickness and Z is channel width. Channel width it is. Okay, and ND is the amount of doping in channel. Q charge of the electron. Mu n is mobility of the electrons. We know that. W naught is depletion region width between depletion region width between gate to channel under open circuit. Okay, under open circuit, that is the depletion region width. Okay, and R naught is the resistance of the channel at equilibrium. Okay, and G naught is called 1 by R naught, that is conductance of the channel under equilibrium. Conductance of the channel under equilibrium. Conductance of the channel under equilibrium. Okay, that is the G naught. So G naught is 1 by R naught. Okay, now what is W naught? We know depletion region width W naught is square root of 2 epsilon by Q into 1 by Na plus 1 by Nd into V naught, contact potential. Okay, now if you check the PN junction, okay, there we have gate is heavily doped compared to channel. Gate doping is much greater than channel doping. That means gate is P plus, it is N, channel is N. That means Na is much greater than Nd. So 1 by NA is much less than 1 by ND. Once 1 by NA is much less than 1 by ND, you can write 1 by NA plus 1 by ND is equals to approximately 1 by ND. Therefore, depletion region width is square root of 2 epsilon by Q into 1 by NA is negligible, 1 by ND into V naught. So 2 epsilon by Q into ND into V naught. That is the depletion region width. Okay. That is the depletion region width. Now, here by applying the, in this FET, by applying the voltage at gate terminal, the depletion region width W is going to be varying. Depletion region width W is varying. Once width is varying, resistance of the junction is varying and conductance of the channel is going to be also varying. Okay, so therefore by changing the, or by applying a gate voltage, the depletion region width by changing a gate voltage, the depletion region width between gate and channel varies and extended more towards lightly doped region. Extends more towards lightly doped channel region. Therefore, channel resistance is going to increase. Therefore, channel resistance is changing. Resistance is changing. Once resistance changing, conductance also changes. Conductance also changes. Conductance also changes. Now, this change in conductance, okay, by changing the gate voltage is called conductance modulation. Okay, therefore, the change in conductance by change in gate voltage VGS is known as conductance modulation. Okay. Conductance modulation. So this is the one of the important term you need to be considered. What is conductance modulation? Change in the conductance with respect to change in so this change in conductance by change in gate voltage is known as conductance modulation. Okay. Now this is the basic information everybody should know about the Jfet. Okay. Now we are going to operate it. So now I'm moving to operation. This channel. Now we are going to operation. In this first step I'm going to keeping the VGS constant first I'm keeping VGS constant and changing VDS. VGS. Sorry, VDS. Changing VDS. Okay. So VGS constant we are keeping and changing the VDS. Now this is called, first we are going to drain characteristics, we call it drain characteristics or drain or output characteristics. Drain or output characteristics. In that first I am keeping VGS constant and changing VDS. So step 1, this, let I am taking VGS 0 first, VGS 0 and VDS also 0, VDS also 0. In that case we know how our FET is like this. This is the, our FET is looks like this. We are not applying any voltages. There is a P plus purity doping this side, another P plus impurity doping another side. It is a drain, it is a source, This is the gate terminal. So we are not applying any potential. There is a depletion region here, and this is the channel. So full channel is available for conduction. So full channel is available for conduction. Once full channel is available for conduction, if you are providing a sufficient voltage between drain to source, you get the conduction. Now the VGS is going to useful to control the channel. VDS is going to useful to get the conduction through the channel. Okay. This is very important point, sir. VGS is to control the channel. And VDS is to get the conduction through that channel. To get the conduction through that channel. Now, this is about VGS and VDS functional purpose. Now, I am going to taking next step also. No change in VGS and small VDS, small value channel. So complete channel is available for conduction. Okay. Now small values of VDS. For this small values of VDS, for small values of VDS, no change in channel, no change in channel. Okay, no change in channel. So maximum channel is available for conduction. Full channel is available for conduction. Full channel is available for conduction. For conduction. So once full channel is available for conduction, now the current is so full channel is available for conduction. It's taking time to copy that. Now see this. Now this is the FET we have. This is the Jfet we have. This and P plus. This and also P plus. So here this is the drain and it is the source. there is a depletion region gate terminal. This is our FET. Now you are applying VGS equals to 0. That means VGS is equals to 0. And I am going to applying some VDS. So some VDS I am applying. That too, that VDS value is variable one. It is variable one. Okay, we are varying this. Now, once VDS is increasing, this is positive and it is negative we mentioned. Now, whatever the electrons present in the channel, that electrons are moving this side. Moving this side. So once electrons are moving from source to drain, there is a current from drain to source. We called it ID, drain current. So ID is drain current. ID is drain current. Okay. Now, just before we calculated the amount of resistance applied by this, and in this case, at the condition of this one, what happens is, for small values of of VDS, you are saying that complete channel is available. Okay, so not much change in the channel, not much change in the channel. So not considerable amount of changing takes place in the channel. Okay, so at that time what happens is, now if you plot voltage and current, this is the drain current ID and this is the VDS. By increasing the VDS, ID is going to be increasing. Why? Because channel is available. There is no controlling here because VGS 0 you are taking. No controlling mechanism. Okay, so for small values of that, your current is increasing like this, like this, like this. This is for small values of VDS. This is for small values of VDS. Okay. Next. Now I am going to continue to increasing VDS. Step 3. Now VGS 0 I am taking and VDS is increasing. Now that means here VDS is greater than contact potential. Greater than contact potential. That means a considerable value. Previously VDS is a small value compared to V0. Now it is more than that. That means a considerable value of VDS we are going to be applying. Okay, now by increasing VDS, the channel resistance also changes. By increasing VDS, the, the depletion region in the channel at the channel extend more towards drain end and drain end and less towards source end. Now, what is this extending more towards drain end? What is the meaning of extending towards source end? I will explain that. This. Now, let us assume that this is going to be Jfet. This is going to be Jfet. At this end, there is a P plus impurity. We call it as a gate. Both the sides. Both the sides. This is P plus. And this is drain and it is source. We know that. Forget about it. VGS is 0 we applied. Now here we are applying some VDS. We are applying some VDS. Initially, there is a depletion region here. Depletion region is there. There is a depletion region. Okay, it is a gate terminal. This is a gate terminal. VGS 0 we are applying. Okay. Now, see here. This is the important thing, sir. Just before we calculated the resistance between drain to source, RDS, resistance between drain to source. drain to source resistance. Drain to source resistance. Okay, in this drain to source resistance, I'm going to representing this drain to source resistance like this. This is the RDS. This is the RDS. Now, this value of RDS, now we are applying VDS from this side. RDS is there. V is equals to IR. Now the current through this one is ID. For small values of that, complete channel is available. That's why we can write RDS can also be written as, in terms of VDS, VDS by ID. VDS by ID. Okay, VDS by ID is the RDS value. Now by increasing VGS, VDS, what happens? Now we check it. Let us, this value of RDS is, just assume that is 3 kilo ohms. Now the 3 kilo ohm resistance is not available in our lab. At that time what we do? We take 3 1 kilo ohm resistors and we connect all the 3 1 kilo ohm resistors in series. The same thing I am going to be doing here. Now, so this is P plus and this is a drain source. Okay, here is a gate. Gate. Now, under steady state conditions, there is a depletion region here. There is a depletion region here under open circuit conditions. Just before we discuss, it is P plus, lightly doped n-type. Fine, leave it. Now, VDS you are going to be applying. There is a resistance between drain to source RDS. Now that value is not available in lab. Now I am going to splitting RDS. Splitting RDS. Now after splitting, the resistance RDS is like this. Like this. Now the sum of these three resistors is equal to RDS. Now see this is important thing. Here P plus, that means, and P plus, and this is lightly doped n-type semiconductor. This is a lightly doped n-type semiconductor, we know that. And this is P plus. Now here we can assume a PN junction like this. Similarly, here also you can assume another PN junction like this. And the same way, here you can assume another PN junction. Here you can assume another PN junction. The way how you assume junctions at this end, this side also you can assume the junction the same way. Now, this is the junction I am assuming at this end. This is the junction I am assuming at this end. Like this. Now, I am giving some number to this for better understanding purpose. Let us take diode 1, diode 2, diode 3 and diode 4. That means junction 1, junction 2, junction 3, junction 4. For these all these junctions at this end, if you observe, the potential at this point is equal to 0 volts because VGS is equals to 0. Okay, so this is connected to gate, and between gate to source voltage is 0, VGS is 0, and let VDS is 9 volts. Let us assume it is 9 volts in this. Okay, 6 volts. Let us 6 volts means the voltage at this point with respect to this point with respect to source is 6 volts. That is the meaning of this. If you assume 3 are equal resistors, the voltage at this point became 4 volts and voltage at this point became 2 volts. It means for diode 1, P side connected to 0, N side connected to plus 6 volts. For a diode D2, P side connected to 0, N side connected to 4 volts. For diode D3, P side connected to 0, N side connected to 2 volts. For diode D4, P side 0, N side 0. That means the junction at drain end is more reverse bias compared to junction at source end. Okay, therefore diode junction, therefore D1 is more reverse bias compared to all. Next, D2 is more reverse bias compared to D3 and D4. Similarly, D3 is more reverse bias compared to D4. That means reverse biasing of junction is more at drain end, less at source end. Therefore, reverse bias of junction at drain end is more reverse bias compared to junction at drain end, source end. Junction at source end compared to junction at source end. And the amount of reverse biasing is, see, once it is more reverse bias, more depletion region. That too, the reverse biasing is, the amount of reverse bias is decreasing from drain end to source end. Therefore, the amount of reverse biasing of reverse bias voltage decreases from drain end to source end. Source end. Therefore, depletion region is more at drain end and it decreases by moving towards source end. Source end. Okay, so this is the very important point, sir. Just before we observed, this junction is more reverse bias compared to this, and it is more reverse bias compared to these two. It is more reverse bias compared to this. So anyway, junction D1 diode is more reverse bias compared to all. That's why more depletion region. D2 is compared to D1. D2 is less reverse bias, less depletion region. But it is compared to D3, D4, it is more. Like that. Because of that, at the drain end, there is a more reverse bias. That's why more depletion region at the drain end. At source end, less reverse bias. Okay. Now, so the remaining part we complete in the next session. So I'm thanking one and all for spending your valuable time with us. And don't forget to use my code VRAO10 during subscription. And don't forget to subscribe us. Hit the bell icon for getting the notifications. Join our Telegram group to get the latest updates on our upcoming videos. And please give your valuable comments to us in YouTube to strengthen ourselves. And join our Telegram group for getting latest updates on our upcoming videos. And once again, I'm welcoming you all to this beautiful online learning platform, Unacademy. Okay. Now, thank you very much. Once again, I am welcoming you all to this beautiful online learning platform. Thank you very much.